Physics Part 252. Section questions. A parallel plate capacitor has rectangular plate of side 200 mm by 30 mm. The plates are separated by an air gap 0.50 mm thick. The permittivity of free space is 8.85 into 10 power raised to minus 12 Fm. Calculate the capacitance of the capacitor. B. The capacitor is connected to 12-volt battery. Calculate the charge on each plate. Calculate the electric field between the plate. Question number 2. The figure shows an arrangement of the capacitors. Calculate the capacitance of this arrangement. The 4U farad capacitor is disconnected. Calculate the new capacitance. Number 3. 10U farad capacitor is charged from a 9.0 V battery. Calculate the electric potential energy stored by the capacitor. Calculate the charge stored by the capacitor. The charged capacitor is discharged through a 150 kilo omega resistor. Calculate the initial discharge current. Calculate the time constant. Identify the time constant. And calculate the time taken for the current to fall to 3.6 into 10 power raised to minus 5A. Next, we have got the topic of gravitational fields. At the end of this section, you should be able to recall and use Newton's law of gravitation in the form F is equal to G m1 m2 divided by r square. You should be able to show an understanding of the concept of the gravitational field as an example of a field of force. Define gravitational field strength as force per unit mass. Derive from Newton's law of gravitation and the definition of the gravitational field strength the equation G is equal to Gm over r square for the gravitational field strength of a point mass. You should be able to recall and solve problems using the equation G is equal to Gm over r square for the gravitational field strength of a point mass. You should be able to define potential at a point as the work done bringing unit mass from infinity to the point. You should be able to solve the problems using equation theta is equal to minus Gm over r for the potential in the field of a point mass. You should be able to recognize analogy between certain qualitative and quantitative aspects of the gravitational field and electric field. You should be able to analyze circular orbits in inverse square law fields by relating the gravitational force to the centripetal acceleration it causes. You should be able to show an understanding of the geostationary orbits and their application. Force between masses. We are familiar with the fact that Earth's force of gravity is responsible for our weight. The force which pulls us towards the Earth is called gravity. Isaac Newton concluded that Earth's force of gravity is also responsible for keeping the Moon in the orbit. His calculations showed that the Earth's force of gravity extends into space but weakens with the distance according to an inverse square law. That is, the Earth's force of gravity varies inversely with the square of the distance from the center of the Earth. If you go to Earth radii from the Earth's surface, the force is greater.